University Calculus. This is YC Mathematics and Physics. Telephone number 416-648-7783. If you have any questions, just call this number. So this lecture is about derivative. We will start the discussion by an example. Find the derivative of the function y equals x cubed. How do we find the derivative? We are going to use a formula to find the derivative. The formula is this. The derivative of y equals x to the power n, this is a general power function, y equals x to the power n. What is the derivative of this function? The answer is this. The derivative is n multiplied x to the exponent n minus 1. This y prime represents the derivative of y. It's just a label. So what is our answer to this problem, to this example? What is the derivative of the function? Use this formula. You see the n, the exponent goes to the front. The 3 goes to the front. We keep the variable x, and the 3 will be reduced by 1. Therefore, the 3 goes to the front. The exponent 3 is reduced by 1, so the exponent becomes 2. So the answer is the derivative, this is a label for derivative, the derivative is 3x squared. You can write y prime clearly in terms of the variable x. So you can write y prime of x. So the derivative is a function of x. Let's discuss what we have here. If we let x equals 1, then you put 1 into the x into the function here. Then the result is y equals 1 cubed equals 1. So y equals 1. When x is 1, y is 1. This means the coordinates 1, the x coordinate 1 and y coordinate 1 is a point, gives you a point. 1, 1 is a point. And this point is on the graph of the original function. How about x equals 1 for the derivative function? So let's do that. For x equals 1, the derivative function is the derivative equals 3 times x squared. So x is 1. Therefore, y prime, the derivative is 3. This is the value of the derivative at the given point 1, 1. What does that mean? The derivative has a value 3 at the point 1, 1. What does that mean? The meaning is here. The derivative function y prime of x is the slope of the tangent line drawn at any point on the graph of the original function. You must understand that a function has variable y and x. And y and x represents the y-axis and the x-axis, so the function can be represented by a graph. So let us repeat the meaning of derivative function. The derivative function is the slope of the tangent at any point. The tangent is to the graph. What graph? the graph of the given function, given original function. All right? Yeah. This is the meaning of the derivative. Derivative is the slope of the tangent. So this is the meaning of derivative. Let's go back to the example. Now, our derivative is 3. The value is 3. Our derivative value is 3. Therefore, the slope of the tangent is 3. What tangent? The tangent must be drawn at the point 1, 1. So if you draw a tangent at a point 1, 1, and if you find the slope of the tangent, how do you find the slope of the tangent? You do rise over run. Understand? You do rise over run, and you will see that the slope is 3. It may be roughly 3 because the graph may not be accurate enough. But you can verify that the slope is almost 3. If you draw it nicely, it is 3. I want you to do this. Do a table values for this function. Y of x is equal to x cubed. For this function, please do a table values. Once you have the table values, you can plot the function and use a graph paper, okay, so that your graph looks nicer, looks very nice. Okay, good. And on this graph, you look at the point 1, 1. And then draw a tangent at this point to the best of your skills. You draw a tangent at this point. And you measure the slope. How do you measure the slope? You measure the rise, and you measure the run, and the rise over run is the slope. Well, actually, it's not measure the slope. Actually, it's to calculate the slope by measuring the rise and measuring the slope, measuring the run. So, and you should, if you do this, you should have a slope roughly equal to 3. So this is my example to illustrate the derivative using the formula. And we explained by doing this assignment, the derivative is the slope of the tangent if you draw the tangent at the point given. So given point means your x coordinate must be given, all right? So do you follow this? If you don't follow, call this number. Okay, call this number. And the next, because this is a quite simple example, so you can do something similar to the example as an exercise. So let's do some problems. You are given 3 functions, A, B, C, and I want you to find the derivatives. Find 3 derivatives for the 3 functions. And how about tangent? So find the slope of the tangent. Remember, the slope of the tangent is at a certain point. Then my point, I give you the x coordinate. X equals 1, that's 1 point, and x equals 2, that's another point. So use the formula given to find the derivative, and please do this problem. It should not be difficult, right? Yeah. So there is a name for the formula I given to you above. The formula for the derivative, in this case, is called a power rule. N is the exponent. So for part A, the n is 7. For part B, n is, what is the exponent for a square root? It's 1/2, is it? This is the same as y equals x goes to the exponent 1/2. So n is 1/2. What is n in part C? It's -2. So I I put down this. N can be a positive number. N can be a negative number. Or N can be a fraction. That's all for today's lesson. This is lesson 1. And it's an easy lesson. So just relax and take a break. If you have any questions, remember to call this number. Thank you for watching and see you next time.